Titration calculations at GCSE relies on using this one formula. The number of moles of a substance is equal to the concentration multiplied by the volume. If you come up with a question like this one, then you can tackle it using these simple steps. Firstly, divide your working out into two sides, the known and the unknown. In this case, the unknown belongs to the value that we're trying to find out. In this example, that's the concentration of the sodium hydroxide. So our alkali is our unknown and goes on the right side. Our known value is the acid, and this goes on to the left. Now let's use that equation to start the question. We firstly need to find the number of moles of the known. We can do this as we have values for both the concentration, 0.1 moles per dm cubed, and the volume, 22 centimeters cubed. We can substitute these into the equation, but be careful to check the units. The volume should be in dm cubed, and therefore we need to convert our measurement of 22 centimeters cubed by dividing it by 1000. This gives us the number of moles of acid used, 0.0022. The second step then requires us to work out the ratio of moles used in the equation. Here you can see that the ratio is simply 1 to 1. This means that we require the same number of moles of alkali to neutralise the acid. We can now tackle the unknown. Again, we use the same formula that we used earlier. The number of moles equals the concentration times volume. However, as we're trying to find the concentration, we need to rearrange the equation, and moving volume over leaves us with concentration equals the number of moles divided by the volume. We can now substitute our values in. The number of moles used was 0.0022 as it's in a 1 to 1 ratio with the acid, and the volume we can get from the question is 25. Again, we need to remember to convert this to dm cubed by dividing the value by 1000. We can then solve the equation to give us a concentration of 0.0880 moles per dm cubed.